Hello and welcome back to the Google APIs for Rust and YouTube Uploader development stream. It's Byron speaking. And before lunch, I really have to get this stuff to work. And I think I'm really close as well. Which stuff am I talking about? The null filter. So a filter that is able to find triplets of key equals null tokens in token streams and efficiently forget about them. It basically filters them out. And implementing this is not super trivial and resulted in this beautiful piece of art, I think. And it doesn't even work, that piece of art. So that makes it a piece of shit, I guess. But I guess it's just a few strokes away from perfection. So looking at the pushback semantics here of my buffer, the first thing I know is that I don't need to reserve 3 but only 2 items, which is even better. And yeah, getting rid of this deck here in favor of an optimized implementation that is really just catered to do what we have it to do is something we can do later once it actually works. And there are a few things that still have to work. So here, for instance, even if it would work, we wouldn't be able to parse consecutive pairs of things. And we will need to add another test for that to just verify this. But for now, I'm happy with, I will be happy if that actually works, which should work with our current implementation because we are able to find one piece of thing, then we will basically forcefully skip the other and miss that entirely. I was just thinking, we missed this, then we find this. Okay, no good. So we might actually manage to, so we should manage to properly prune this guy here. If we actually work somehow, but we don't work at all. So as you can see, the results, we expect 5, we get 13, which is the original amount that we have. So nothing changed. And that's kind of odd because, yeah, what the heck is going on? So I don't think it's this. That shouldn't be a problem. But the first one, you know, if it's a string, we should get this. Yeah, let's kill these lines here. So let's just assume we should be here, right? We get this. First string token. What do you say? Do you see something? Yes. So it's 11 to 14. Oh, that's a weird span, man. Oh, no, wait. The first one is 1 to 4. 1, 0, 1, 2, 3. That's exactly right. And then we should get, what's the next we find? 11 to 14. Yeah, so I guess we find all of them, but okay, so we get here, that's good. Let's keep going. So what about the Cullen candidate? Do we get that? We should. Maybe there's some Lexer error as well. I don't think so, but Cullen candidate. Oh wait. We should get here, right? So maybe, okay, first things first. Now that I know, you know, here it's a Cullen candidate, but here I know it's a Cullen. Cullen is Cullen candidate. Good. So now there will be a few things not working because we cannot use Cullen candidate anymore. So here we also can't use it, but here we have to use it. Because here, basically, it means this is not a Cullen. Good. So this remains a Cullen candidate, basically. That makes total sense. So we should see this, but first, second string candidate. Here it is a candidate, but here it stops being a candidate. But we don't have to reassign it because we will never use this again. Only if it's not a string, we will push it and it remains a candidate. So that's the only fix I had to make. Good. So do we get here? Do we find a colon? Do I still have it? Yeah. Colon. Show me. Well, show me. And we get a colon. First one, 4 to 5. That's exactly right. So now we should find a null. Oh, I'm dumb. Yeah. So we could actually make it work now. Show me. Okay, cool. Left is 6, right is 5. So basically we actually get 6 out of there and we assumed it's just 5. So let's see, let's count it. 1, this goes away. 2, 3, 4, 5, 6. So we can't yet remove, that's the point, we can't yet remove this first colon because we don't peek ahead. So we would have to kind of the thing is we could possibly do that, but this goes hand in hand. For now I will be happy with that. This goes hand in hand with our consecutive value parsing routine here, I think. And right now I can't do this. So let's just say, yeah, we have something working here. And that's cool. Also, before we forget about it, iterator, let's call it filters. Because we have filter null. Let's call it filter null then, huh? Let's call it filters, because filters are kind of the bread and butter of this library. So I want to rename this. Git move source, tests, iterators to tests, filters.rs, one for all. And then I would also like to have a benchmark. I guess we can share it. Why not? The only disadvantage is that you can't run them separately that easily then. But I also don't want to copy this bulk of string all the time because I think we will be using that a lot. So let's rename this to what it now will be. Git move tests. Yeah, so we fixed it and we add iterators. Yeah, let's make a commit now before we get ahead of ourselves on stage. Yeah, we will fix this. Fix filter null. Did we call it filter null? Log current. Null filter. There you go. Nearly got me there. Null filter. Minor fix to make it work. It's still far from perfect, but a good proof of concept. Okay, now I want benchmarks because now we kind of start changing this around. It would be interesting to see how this affects our performance characteristics. It's not the most important thing in the world to have right now, but I had it for Lexer and I like it, and I would like to have it here as well because it will be as simple. And this is kind of the combined lexing, because we need to lex it, we need those token stream, and it's kind of the combined performance of that, so it's kind of a real world benchmark. So we want to benches, lexer, benches, usage.rs. I don't know. Is it a good name, bad name? I can rename it anytime. So we will need a lot of this. Oh, name. So that's just the lexer. Alexa throughput. In bytes. That's going to be filter null filter. Filter null throughput in bytes. So how much text can we process in bytes? So that's our iterator. Let's call it F. We will have, where is it? Filter null. All we have to do is filter null new and dump Alexa in there. Like so, and now we have a filter. Can iterate over our filter and be happy with ourselves. That's the test. And see. Cargo bench. Alexa throughput in bytes. Why does it get lower now? Did I have a bad time here? So now all of a sudden my Alexa got slower even though I didn't touch it. For a moment it was a 270. Maybe I wasn't recording. No, I was recording at that moment. What's going on? It's like, oh, I'm in a bad mood. Oh, you've added something to the library and now I decided to change the code in a way that, you know, it's like 40 megabyte difference. I was happy with my 270 there. Interestingly, the filter really doesn't do much. Not at all. Probably because we are actually working on just a few tokens at a time. And it's efficient too. You know, there's no allocation going on. It's just nice, as good as passed through. That's how it should be. So that's good to see. Nice. Let's add these files. Oh man, I can't. This annoying bug and kind of never gets fixed or something. Let's commit that. Yeah. Tests. Is there a chore for benchmarks? Probably not. So it's part of the test. Tests, null, filter, added benchmark. Also renamed files to match their purpose. Renamed test related files to match their purpose a bit better. What's the time saying? 13 minutes. Enough time to go ahead and try something here. So first thing I would like to do is probably amend this. I would like to have more stuff going on here. So let's have consecutive filter things. So that's interesting because that should actually be 6, a 5 here. Because I would like to take out that comma. That could be invalid JSON for some to have a trading comma there. And I'm now producing invalid JSON, right? So we shouldn't do that. 4. Source, what else? Source, count, f count in that. Then we do this. Source we already have, that's good. Count, oh yeah, and that's copyable. That's also a borrow already, that makes it copyable, kind of. And that's the f count. Good. Oh no, not good. We should at least keep it alive as long as we put the values in there. Not in there, but in there. So that's 13 and 6 right now. And then we have another one that is very similar. Same, but different. Good. So let's run this. This should obviously work. Cargo test filters. What? Syntax error? Incorrect close delimiter. This one is entirely missing. For some reason. Here we go. Nah. Oh yeah, true. Dumb. Dumb. It was kind of Python, my Python mind thinking there. Type of this value must be known in this context. Mismatch types. Oh yeah, true. It's read only, so we have to take that into consideration. Okay, cool. That works. And yeah, I should have known that, but I didn't think of it in that moment. It's always difficult from that to understand that. Oh, okay. Actually, expected pointer. It kind of tells you, so I have to read carefully. But it's confusing. You know, the noise around it makes it hard to see what actually is the case unless you're experienced. An experienced rustacean such as me. Oh my god. Okay. Let's manufacture something that it can't do. So to give it all the rest, this should boil it down to just two things. That's 13. It goes down to 2. But it can't do it, I bet. See? That's interesting. So it found... Yeah, so it skipped 1 basically. It has the middle one still left there. And that's how that is. Fine. But that's what we are here to fix anyway. I knew that this would happen. And now comes the loop and the next token logic. The cool thing is, thanks to the loop and the next token logic, I don't think we can be messed with. No one can send us into, because we don't use recursion, we will not have trouble with long streams of null stuff. So the problem is that here, where is it? Yeah, so this one we return, but we actually should analyze it because this could already be a string that we want to take as the start of a possible matching sequence of tokens. But we don't. So what we have to do is we have to set our next token and continue. And maybe we don't. So this is our first token. Some string. Okay, we can't loop here. First string candidate. I think the first string candidate, this is the guy we can possibly write again if we make it mutable. So we can loop here. That would be our loop. So if I make this mutable now, it will tell me, hey, it doesn't need to be mutable. No, it doesn't tell me that. Interesting, I thought it would. Well, there is a warning here. Probably it compiled, yeah, my editor here compiled it and triggered the warning somewhere. Oh no, that's actually a gutter change. That's a change line here. Anyway, let's just, we are clear here. I can mess it up. I can just check it out if things don't work anymore. Oh my god, this loop is dangerous as we have to be sure we are able to terminate it. So this is our match here. This is now our new end and inner string candidate loop. All one to the right, please. Move to the right slowly and carefully. You don't want to hurt your neighbor. Here we go with the loop. And we're not careful now. I don't even want to run it because we have to get our abort conditions clear. The thing is, the entire, with that loop in place, all this sum needs to be a return. Here's the inner loop. And that's return now. That's the first thing that we have to do. Second, first string candidate. We can now assign here. And whatever happens, the result of this thing is a first string candidate. Boom. And that's what we want to do. Make an assignment and continue. Continue. That's the point here. Continue. And now we go through all the bottom parts of the matches and make sure that we actually return to get out of the loop, because we would otherwise never get out of the loop. Return. Return. Let's see what borrow checker issues we have thanks to that. Return. And here's the loop end, so here we also have to return. Here we don't have to return. All right, first string candidate. Here we try to assign it and it hates life. And I wonder why. Show me for real. Did you mean for, because I can't spell? Well, that's something I can live with. And now, okay, what's it? Mismatched types, really? But, what's the difference? Comma candidate? That's a token. We reassign string candidate. What's the... So we have an optional extra token. Ah, now I get it. Sure. And we don't know yet what it's gonna be. So we have to match on it another time. Match on this mother. And now we have a token T here that we shall return. And if the thing is nothing for some reason, this means the next guy is nothing and we return none. That's what this is. And that's going to mark the end of our assignment, which builds. Yes! All right, let's have a few more cases here just for the fun. Let's put the value. Let's put a value at the end and at the a non-null value at the end and at the beginning. Like this. So that's not this is now a true null. Let's make it all V here. All S. Doesn't matter. So true null should now be going down to 6. No. Yeah, because it will not touch this comma here, which it should touch. So that should be, the 6 should be 5. Like this. Here as well. And now we put it to the end. And I think then it's a good time for lunch. So here we have null, and here we have true. And that means comma goes away, and this is the first time where we have 5. That's my guess. And I guessed right. That shall conclude this session. Awesome! And yeah, let's bench it. Let's benchmark it. Because now we can actually filter out many more tokens here than we could before. 231, so we really don't lose a lot. Not at all. This thing is super fast. So I mean, it's really great that we have a super fast null filter now. So let's see how fast the serialization can be. It all depends on how we handle our characters and manage the tokenization there. And I think we can we basically copy stuff together. So there are a few reads and writes, but as long as we are not, we are working on a token stream, on a character stream, so we have to cache these guys. And yeah, I thought about that already, and I will think about it more during lunch, because that's what we have to do next. Tokenize that thing again into a character stream, or maybe even into a writer. I will think about that. Something will work and will be nice. Fix null filter, handle consecutive null values. With this in place, we handle null value filtering pretty well. I'll say we still have to do the comma stuff. Sorry, we are not yet done. Very well, as the tests indicate too. However, we may still leave a trailing comma in non-null values, which could be a problem and thus shouldn't be done. Good, this is what we'll fix, but only after lunch. Thanks for watching and have a good day.